Hello and welcome to a tutorial in Autodesk Fusion. In this tutorial, I'm going to guide you how to do the static stress simulation for a structure like this plane chart. In the first step, you need to move to the simulation workspace. And please create a new static stress study. In the first step, you can simplify your structure. However, my structure already simplified enough, so therefore I don't need to simplify further. I can skip this part. Now I assign material to my structure. I click on Study Material. And if you click on the component, you can assign the material for that. So I use acrylic clear for my arms and the other arm and the connection between them. Now for the component at the end, I have to use a PLA. However, I don't think I have PLA in the default library. So therefore I can choose something that's similar first, like plastic ABS, and I click on OK. So now you can see that the color of the material has changed. Now I need to edit the material property, so I go to Material and Manage Physical Materials. In here, I click on the ABS plastic and I edit it. And I go to the Physical tab. I open the Mechanical Behavior tab and I can enter the value I want. For now, just a simple tutorial. I just keep it at the same. But in your work, you need to adapt it to the correct information. In the next step, I need to put the constraint. So I'm going to have two pins over here. So I'm going to use the structural constraints with the hotkey C and assign to the hole. 1, 2, 3, and the last one I need to rotate it a bit. And 4. So I'm going to have two pins over here. I can choose which way I want to fix it, and I'm fine with this. So I just click on OK. Now, before the simulations, I need to assign the load over here that's going to be pulled by the hook. So therefore, I can assign the load. And I click on the hole. I assign the value of 100 Newton, that's about 10 kilogram. Yep. If you want to change it, you can go to Load, Force, and edit it. You can rotate it to the direction you want. Yeah, but I'm fine with this, so just keep it as it is. You always can change the mesh by click on Edit, and you can choose the mesh size and some advanced setting for that. For this simple tutorial, I just keep it as it is. Now for pre-check, you can see that I have a red symbol over here. That means something wrong. So you can see that I have the fixed support over here, but this detail and this detail are not really fixed. So therefore, you go in to have two fully unconstrained. And you can click on Select Automatic Contacts to create the contacts between the arms and the details. So click on that. If you set the tolerance of maybe 0.2 millimeters, you can generate. You will see that they are not enough. So when you click on this one, you can see again. Now you have one fully unconstrained group. So that means this one is now constrained, but this one not yet. So I have to change the tolerance. I can change it to maybe 0.5 millimeters, and I generate it. Yep. I think it's good for me now because I have a green tick over here and I can solve it. So I click on solve. Yep. I have 0 cloud credit at the moment. It is okay. Fusion has removed the ability to do the local simulation. So I always have to send it to cloud. I click on solve one study. And now it's going to be sent to the cloud and solved over there. It will take a time, so see you in a few minutes. So now the simulation has finished and I have received the result from the cloud. So I just click on close. So you can see here is my chart. As you can see, I have the mean safety factor is 1.16 for the place near the pin over here, and I also have the mark is 15 for the place over here where it has almost no stress. I also can see the stress inside the material. Yep, this is a full spectrum, and I also can focus on the high stress part. Yep, so it can highlight the high stress part. The one misses is the resultant stress. You also can go to the first principal stress or the third principal stress in the Morse circle. You also can choose the direction of your stress as well, where the XX, YY, ZZ are the normal stress, and the XY, YZ, and ZX are the shear stress. You also can see the displacement, and you can see that the displacement is large at the end, where you have the hook to pull the chart down. You also can see the strain, which is the deformations. Yeah. So for most of the crane, you don't have much deformations. Yeah. And if you focus on the part, you will see that it's mostly where you have the hook and possibly where you have the connections or maybe the hole inside the arms. Yep. And you can see the contact pressure over here. Yeah. So Fusion is a very strong tool that can provide you enough information for the static stress simulations. I hope this tutorial can help you to make a good design for your crane chart.